John with lesson 4 for year 12, and this lesson is on force and acceleration. It'll be slightly longer than the other lessons, so bear with me. So when there is an unbalanced force acting on an object, it will cause acceleration. The direction of acceleration will be the same as that of the unbalanced force. How do we know if something is accelerating? These things will happen. It will either speed up or slow down, either start or stop moving, or it could change the direction of motion. So the formula used, which relates force and acceleration, is F equals ma, where the F stands for the resultant or the unbalanced force, and you got the mass and you got the acceleration. Now, what we need to keep in mind while solving problems using F equals ma in year 12 is we need to watch out to see if the direction of the force is the same as the direction of motion. If not, we need to calculate the component of the force in the direction of motion. So this is the gist of the lesson, but then I have a few problems which I've solved, which you may like to take a look at. So here's one question. I've got the answer. Try work it out yourself, and the answers are all here. And here's the next question. You may want to pause your video while you work it out. Here's another one. So when you're doing the resultant force, you always don't forget the direction. So if you're subtracting, then you need to add the opposite. Okay, and then here you go. Here's one more. And then here's this one. And then there's one with the lift. Okay, so this is about the lift decelerating downwards. So if it's decelerating downwards, then the unbalanced force is upwards. Okay, so that's going to be bigger. So it's slowing down as it comes down. So because it's slowing down, the resultant force has to be opposite motion. Okay, and then this is all these problems with the lift. And here is the summary. So if it's decelerating down, then the unbalanced force is up. If it's accelerating down, then the unbalanced force is down. If it's accelerating up, then it has to be up. But if it's decelerating up, then the unbalanced force has to be downwards. And then there's one last question here, if you'd like to take a look. This is about two things that are pulling away. When they're released, they will accelerate away from each other. The main thing is each one will exert an equal but opposite force on the other. And even though their masses are different, so their acceleration will be different, but the product of force, mass times acceleration, should be the same for each of them.